In the last section, we learned the data model of hbase. The third part is about the hbase architecture.
Obviously, this is another typical master and slave structure in hbase. And here we can see a very complex architecture. But don't worry, this architecture is indeed not complex at all. On the top is Zookeeper. Zookeeper provides distributed coordination service for each process in hbase clusters. Each region server is registered with Zookeeper so that the active hmaster can obtain the health status of each region server. So here, does anyone know what is the master node of hbase? Yes, hmaster. Very simple name, right? Then, does anybody know what is the slave node? Alright, it's the region server here. And as we can see, there are many components in the region server. Then we can have a look at the main roles in hbase architecture. There are library functions, hmaster, region server. As we mentioned before, hmaster is a master node, and a master node is a boss. So hmaster manages multiple region servers in hbase, and the order includes creating, deleting, modifying, and querying table, balancing the load of region server, adjusting the distribution of regions, splitting and distributing regions, and migrating regions after a region server failed. There are quite a lot of responsibilities, right? But this is very important, okay? We say hmaster manages region server, but what components manages the hbase region? Actually, it is region server that manages it. Region server provides read and write service of table data as a data processing and computing unit in hbase. The reading server is usually deployed with the data nodes of HDFS cluster to store data. All reading and writing requests of user data are handled based on the interaction among regions on region server, and regions can migrate it between region servers. When we read data from hbase, client does not directly contact the hmaster. Instead, the client directly reads data from each region server after obtaining the storage location of the region. In addition, the client does not depend on the hmaster. It obtains the region location through Zookeeper. Most clients do not even communicate with the hmaster, and this design reduces the loads of the hmaster. We can see the inner storage architecture in hbase. We know that the data stored in hbase by table, and one table can be vertically divided into many regions. Then a region consists of one or multiple stores. Each store corresponds to a column family. So each vertical part corresponds to one region, and each horizontal part corresponds to one column family. Then a store contains one mem store. Would you want to have a guess what is the fundamental hardware of mem store? Yes, it's memory-based, so it is very fast. Data inserted to a region by client is cached to the mem store. When the mem store capacity reaches the upper limit, region server flushes data from the mem store to HDFS as store files. And that is called a persistent process. As more data is inserted, multiple store files are generated in a store. Please remember, when we write data into hbase, it will firstly be read into the mem store, and then flushed to disk as store files. This process will extremely improve the efficiency. When the number of store files reaches the upper limit, region server merges multiple store files into a big store file. Each file defines the storage format of store files in the file system. Each file is actually the underlying implementation of store file in hbase. And each log prevents data lost when a region server fails. We say that the data needs to be inserted into the mem store, which is based on the memory. But data stored in memory lacks persistence, right? So if a region server fails, all the data in mem store would be completely lost. That's why we need hlog here. We can write the data into hlog before writing into mem store, and hlog is disk-based now. Please note, multiple regions in a region server shares the same hlog. Although not definitely, in most cases, one region server has only one hlog. Obviously, we have talked about a region for several times. What exactly is a region? In hbase, a data table is divided into subtables based on the range of key value to implement distributed storage. A subtable is called a region, just like the left side of this figure, which is the most basic distributed storage unit in hbase. Okay, region is the most basic distributed storage unit in hbase. Here we emphasize the basic distributed storage unit. Each region is associated with a key value range, which includes a start key and an end key. Actually, we only need one of them, usually the start key, because we can use the end key as the start key of next region. After that, a big region can be split into many small regions. Region splitting is fast because region cannot be read during the splitting. The region reads the new file only after the storage file is asynchronously written to an independent file. And for regions, there is another important concept. As we can see, there are two types of regions, meta region and user region. So what are differences? Do you remember the name node and data node in HDFS? The name node records the routine information of data nodes, and we store the original data in data nodes, right? And indeed, it's almost the same thing here. The meta region records the routine information of every user regions, and we can search the user region via the information in meta region. But we also need to search for our meta region. So where do we store the address of meta regions? Actually, I have told you that Zookeeper also serves as a micro database. And what data need to be stored into Zookeeper? The answer is clear no. The routine information of the meta region needs to be stored into the Zookeeper. In the following part, we will review some key points again. The client in hbase contains the interface for accessing hbase and maintains the location information of the accessed regions in the cache to accelerate the subsequent data access. The hbase supports the HA, which is a high availability as well. That is to say, hmaster is in active and standby mode, which means that when a Zookeeper helps to manage the HA cluster, it has two hmaster processes. When the cluster starts, the processes compete an election for being the active hmaster. This is very much like our human beings, right? We all need election for choosing a leader. And there is only one active hmaster in a cluster. If it fails, a new one will be made by Zookeeper. So there is another key point. How is active hmaster elected? The answer is judging through Zookeeper, okay? This means we need Zookeeper being the adjudicator to make judgment. Alright, this slide shows how hmaster manages region server in details. Let's review it again. Migrating regions after a region server failed. Creating, deleting, modifying, and querying a table. Balancing the loads region server and regions. Adjusting the distribution of regions. Splitting and distributing regions. We can find as a master node in the cluster, the hmaster manages the data at a table level. And for each region server, which is similar to the department manager, manages the regions on its server. It provides read and write service of table data as a data processing and maintains the regions located as well.
In this section, we mainly focus on the master and slave structure of hbase and even introduce the main roles. Next, we are going to learn the read and write process.